Hello Squids, this is Squeezy here with another tutorial. In this tutorial I will be doing neural networks. Now, before I get into this, what is a neural network now? A neural network is just a whole bunch of neurons that are interwoven, and they pretty much just pass data between each other until they get a goal, and they learn from that how to do things. I mean, I'm not going to go into machine learning just yet. That's support vector machines, which is something we'll get to in the next tutorial. Today we're just running a single neuron, and the next tutorial will probably just make a couple interwoven neurons to get an output, and just keep two neurons and just keep passing neural data back and forth until you get something good. Anyways, today's just a single neuron. So how does a neural network work? Well, basically it takes a number, and that connects to a neuron, which uses a sigmoid function to squish that between 0 and 1, then it sends that data to another neural network, which keeps putting sigmoid functions and crushing things down until it reaches a goal. And, you know, in a more practical example, it would probably use, like, I don't know, not sigmoid functions, it uses a support vector machine. So anyways, let's get working. So, let me just do something. I don't know if that created some sound. Very, very sorry. So, alright, suppose we had a sigmoid function, right? And we have the data inside of it. We have that data. Sigmoid function. This is a sigmoid. Get your mind out of the gutter. I know you're thinking about it. One of you's thinking about it. Because when I first saw sigma, I was like, yep, that's what it is. Okay? And then, so what does a sigmoid function look like? Well, it's just 1 over 1 plus the exponential to the x. And I'm actually going to code this in just a second. Show you the code. So this here's your sigmoid function. This here is your actual function. So let's hop on over to Python and let's start coding. So from first you can say from math from math. Did I say this is from P1? From math import the exponential, and hello Sunny, this is my cat. She's a kitty cat. She does cat stuff all day long. Don't you, Sunny? She's a cat. Yes. She's adorable. She's right here on my chair. So we do that. Oh, no. Exponential. Now we need to create some, functions. So let's, multiply. Go to multiply. Okay? And we're just going to multiply x by y. So this is our multiplication gate. I'm not going to go into the absolute basics because it's really simple and it's not worth an entire tutorial. I'll just link you to a website online where you can read up on more neural network things. So that's all it's going to do. That's our multiplication gate. And that's what I mean. The gate is really simple. It's just a logic gate that does things. I mean, if you look, when you look at the tutorial, you'll see forward and backward gates. That's something you use when you're dealing with bigger networks. For the single neuron, you don't. I tested this out; it works just fine. Alright, so we need to define. Bye, Sunny. We need to define an add gate, and then we need to define a sigmoid gate, which we'll get to in just a second. And I bet you can't guess what this is going to do. So, hold on. I bet you can't guess what it's going to do. You can't guess. You guessed it. X plus y, and then we just sigmoid. join sigmoid. I'm just going to take a single parameter, x. I'm just going to return 1 divided by 1 plus x and negative x. Yep. Okay. Now all we gotta do is create an A, B, and C. A is going to be 1. C is going to be equal to 2. C is going to be equal to minus 3. Okay, so that's just some data we're passing in to the, this is just data we're passing into the, that's just, the data that goes to the single neuron. That's, and then X and Y are the, I guess you can imagine them kind of like weights. They sort of push the neural network to places. I mean, when we do machine learning, vector support machines, or support vector machines, we'll actually do more weighting. But you know, this is just something that we use to tweak what we get. So X and Y just tweaks what we get. X is going to be equal to 1. Y is going to be equal to 3. Those are our tweak values. Alright, AX is going to be equal to multiply AX. Now the reason I'm doing the gates, I mean, you could do this really simply with just like a couple lines of codes, but I want you to visualize the gates and how it works via the code. So, yeah. By is going to be equal to multiply B and Y. Alright, and then AX BY, so it's these two added together, is going to be equal to add AX and BY, and then AX BYC is going to be equal to add AX BY and C. And then the neuron value is going to be equal to the sigmoid of AX BY C. You can just do print single neuron printed value. Okay. Oh, okay, where is it? Oh, I forgot the equal sign. How silly am I? And apparently you can't do this. I was thinking something like Java, but apparently not. And I guess we're not doing that. Oh wait. Like that. Okay, there we go. And that's what we printed. Something's wrong. That's not what we should have printed. Yeah, we should have printed that. Where's the error coming along? 1, 2, and negative 1, that's the error. Negative 1. Those are our tweak values to get our neuron value. Yep, that's our correct value. So a single neuron printed this value, which basically is just, I mean, it means nothing to you now, but it will later. When you string neurons together, they're all going to pass values like this, and it'll train, it'll start passing other values like this, and it gets very complicated after a while. But that is the absolute basics of a neural network. Don't get me wrong. This isn't hard, And a lot of you will probably say, oh, it's just one algorithm. I mean, it's just like a couple lines of algorithm. It looks simple, but it leads to a lot. It has a lot of weight in neural networking. I mean, the sigmoid function is pretty much the key factor of the neural network. Like the single neuron you have to do before you do any fancy neural networking. So, thank you all for watching, and as always, I'll see you in the next tutorial. And don't forget to like, comment, subscribe, and become a squid. Au revoir.